goal of our discussion is going to be to show that for all linear transformations from Rn to Rm, there exists some matrix A, and that matrix is going to be of size m by n, such that the linear transformation of the vector x is equal to A multiplied by the vector x. For a quick review, we'll discuss the discussion of a linear transformation. So a mapping L is a linear transformation if we have that for all v1 and v2 in Rn, we have that L of v1 plus v2 equals L of v1 plus L of v2. We also have that for a scalar alpha and a vector v, we have that L of alpha v equals alpha L of v. Okay? I also want to go over one notation note before we begin our proof. If we are discussing the vector e sub I, then that is going to be a vector that is filled with zeros, except in the ith place there will be a single one. And this vector is in Rn, so it has n values total. Okay, now let's look at our proof. We will examine the linear transformation of a vector x, which we can write as x1 through xn. We can rewrite this as a sum of vectors with one value each. So we have x1 and all zeros plus 0, x2, all zeros, plus so on until we get to our xn. So we'll have n vectors here. And we can write that sum as a sum from 1 to n of x sub I times e sub I. Because L is a linear transformation, and it has the properties that we just discussed, we can rewrite this as a sum of linear transformations instead of a linear transformation of sums. And then we can rewrite this as a matrix, L of E1, the second column is L of E2, all the way through En, multiplied by our original vector, x1 through xn. So we see that this matrix here fits our requirements for A. Let's look at a quick example just to get a better handle on things. Let's examine the linear transformation from R3 to R2 that is represented by the linear transformation of x1, x2, x3 equals the vector x1 plus x2, x2 plus x3. We want to find our matrix A. So we think back to our proof and we know that the first column of A is going to be equal to the linear transformation of E1, which is 1, 0, 0. So we get 1 plus 0 is 1, 0 plus 0 is 0. Our second column will be the linear transformation of E2. So 0 plus 1 is 1, 1 plus 0 is 1. And our third column will be the linear transformation of E3, which is equal to 0 plus 0 is 0, 0 plus 1 is 1. Okay. We can test this with any vector in R3 that we choose. Feel free to test it with as many as you'd like to confirm what I'm telling you. I am going to choose just an arbitrary vector. Let's go 3, 1, 7. The linear transformation of 3, 1, 7 is 3 plus 1 is 4, 1 plus 7 is 8. When we multiply A by the vector 3, 1, 7, we get 1 times 3 plus 1 times 1 plus 0 times 7 is 4. 0 times 3 plus 1 times 1 plus 1 times 7 is 8. So we see that the linear transformation of x equals ax.